Hi everyone. Okay, so we will be doing an analysis on this brilliant article by DoorDash team related to building faster indexing with Apache Kafka and Elasticsearch. The core thing which we will be discussing is the CDC. So let's look at the application related CDC related point. So here in this paragraph they have shared that like they have explored the option of change data capture mechanism by using the Debezium connector, okay, which captures the low level changes either in Postgres, MySQL, MongoDB, okay, and different other databases. So then that data is produced to the Kafka. Then we can further publish it to Elasticsearch, MongoDB, DynamoDB, or even place it onto S3 or produce to Postgres. The destination can be anything which Kafka Connect supports. So they have explored that. Then the other option was like application level CDC. Actually, this is the important thing which I wanna discuss. And you will get the idea once I will show you the change data capture related bottlenecks or cons of that area. The whenever we have a a relational database, of course it has a normalized tables, okay, normalized structure for storing the data to have data integrity. So in that case we store the IDs of the reference tables instead of storing the values. But in the case of querying, okay, we need to join those tables to get a complete picture. Like we can an ID of a product is not something in which a user is interested in. So user wants the product name or description or product price, so we want to show that. So it might possible an order has a product ID in a relational database, and we wanna ingest those different tables using Debezium into Kafka, and wanna create a materialized view. So there are certain ways to do that. One of them is creating a materialized view in Kafka Stream application. So in order to do that, you can have like a stateful Kafka Stream application in which one stream ingests the changes from product and the other one ingests the changes of order table, okay. So then you join those stream to stream and then denormalize or construct an object with all of the information or denormalized view and produces back into Kafka. Then that is being that will be used in produced to the Elasticsearch, so that it can be queried efficiently, okay. So basically this is the main idea, okay. So whenever we use change data capture mechanism, okay, so it ingests the table level or row level changes, and then the other approach is application level CDC. We will come back to the application level CDC. First let's look at the challenges which change data capture mechanism on the using the Debezium and the Kafka and the Kafka streams can potentially come up, okay. So let's look at this example, okay. So we have like SMS recipient K table which ingests the changes of SMS recipient status, okay. So we are basically doing the group by, then we are just aggregating on that and then the building the materialized view, okay. So let's assume for a second we have 1 million records in it, okay. So now, okay, so we are also need to have something like here we have this join, okay, this join, okay. So this is actually basically trying to join two table like SMS link table, participant K table, okay. So these are, one has 1 million rows, second has 1 million rows, okay. They are joined, and when they will be joining, they need to traverse through the whole 2 million records to have a join on, apply a join on that. So in that case, let's assume for a second updates and update comes on happens on participant table. Okay, so in that case we have the 1 million and 1 million in SMS link and 1 million are being processed, and we wanna immediately accommodate that change as well, but it cannot be accommodated unless this process of joining those two streams or those two table of Kafka stream are not completed. Whenever this process is completed, okay, then that event will be processed, like it will be the last record which will be processed after 1 million. Okay, so the time it will take, of course, if we have a better CPU, better computation, then it will be quicker or seamless. But in case of 50 million records or 60 million records, or sometime there is an influx of data comes in and you have a very critical update you wanna have in Elasticsearch, like for instance a participant has been deleted. Okay, you don't wanna wait for even 1 minute, okay, to publish that change to Elasticsearch. You wanna have that immediate published to Elasticsearch instead of getting through this pipeline. Okay, so this is the area where, okay, this is the area where something can cause performance issues for the critical things. Okay, when we are building denormalized views, okay, using Kafka stream stateful processing, okay, where we are using join. And let's assume for a second you have used map. Okay, you has used a map. Okay, in that case it has like we are mapping different data like for denormalized view, right? So in that case it also causes internal redistribution. Okay, it can also cause internal redistribution. It does mean that in that case, okay, let me show you that output key. Okay, here computer and state record be okay, so here it get mapping record might result in internal data redistribution. Okay, what does that mean? Okay, so we are processing 1 million record for it, 1 million records for it, like 2 million records, and we are combining those records or joining those records. Okay, so in that case 2 million records has been processed here, then we are selecting a key, okay, key value, then it Kafka stream will process that those record again, like 2 millions again. It will reprocess those records. Okay, it will be now 4 million records, which you are going to process just using like these two functions, and you wanted an immediate delete operation to be reflected in Elasticsearch and happen on a particular table, and you want immediate reflected in Elasticsearch it or DynamoDB or wherever you have store where you are querying from. Okay, so this is the area where it can also be a bottleneck for in terms of performance or processing. Of course you can scale this out. Okay, you can have multiple instance of this application running. Okay, I have like multiple application running, like I can locally run it. Okay, so this is how you can achieve the scalability in Kafka stream. Like you can deploy this application on 4 different EC2 instances or virtual machines, okay, or 8 machines. But in that case you need to have multiple partitions. If you have 8 partitions, then you can deploy scale it out to 8 different machines. But if you have only 1 partition, in that case it it can be only processed by one machine only. Okay, so these are the things which can be easily accommodated if you the resources are limitless. We don't have any worry about, we don't need to worry about the AWS bill or something like that. Okay, so in that case the database level events, okay, CDC to produce a denormalized state based on those CDC streams using a Kafka Streams stateful service can cause something like issues in the, as I have mentioned in the case of delete operation. There might be any other ways as well. Kafka Stream have a lot of benefits, so I just wanted to show you sometime it is necessary to have this kind of operations to be treated a bit differently. Okay, it is significantly better than other solutions in terms of denormalizing the different streams. Okay, and one of them is application level events, which here we the DoDash team has suggested. Okay, so what does it mean? Okay, as soon as the delete operation happens on the table, we are going to, like any delete operation on the participant table goes through any code, right? Whenever user interacts with a participant, like it has been removed, then it will go to any application. Okay, in that case we need to produce it to Kafka Topic. Okay, and the Kafka Topic, this is the important thing. We produce the Kafka Topic, and that topic has a sync connector, okay, already listening on for that particular events. Okay, so it will be automatically like you can query the same denormalized view, like you can have a view in Postgres which produces the same data as this pipeline is producing. Okay, so yeah, just what I mean, like this model, actually you are interested in this model. Okay, just produce this object into that topic. Okay, in that topic, and the Kafka sync connector for Elasticsearch will ingest that immediately, and your delete operation will be available to view for the clients in no time. Okay, so these are two approaches: change data capture mechanism for database level, and the other one is application level. You should be accommodating or using hybrid approach in this kind of behavior, where you have to have a better performance. Okay, in terms of where urgency is not negligible. Okay, so this is the whole point which I wanna explain for a very long time.